5.4. Solve compound inequalities. A compound inequality is two separate inequalities joined by and, or. The graph of a compound inequality with and is the intersection of the graphs of the inequalities. So let's say if I graph x greater than -2, so I'm just going to mark this as 0, line it up, okay? And -2 would just be here. And to graph this, it will be everything to the right. And for x less than or equal to 1, it will be everything to the left, including 1. So both inequalities can be written as -2 less than x and x less than or equal to 1, or simply -2 less than x less than or equal to 1. And we can graph the solution as follows. So if I were to ask you to graph a compound inequality, you would have to do it like this. The graph of a compound inequality with or is the union of the graphs of the inequalities. So to graph x greater than or equal to 0, I'm going to let this be 0, inclusive. I will have to graph everything to the right. Okay, I'm going to mark this as 0 as well. And to graph x less than -1, and have an open circle, and graph everything to the left. So both inequalities can be written as x less than -1 or x greater than or equal to 0. And so the answer, or when we graph these inequalities together, we simply mark both sides of the graph. Guided practice. Part A. Translate the verbal phrase into an inequality. Then graph the inequalities. All real numbers that are greater than -2 and less than or equal to 3. So this would be how you translate a verbal phrase into an inequality. And now I'm going to graph this. So -2, I'm going to first mark where my 0 is. -2 is going to be right here. I'm going to open circle. And 3, 1, 2, 3, close circle. And graph everything inside of it. Okay, and see all real numbers that are less than 0. Okay. X less than 0 or greater than or equal to 2. So after translating this, I can graph this. X less than 0 will be everything to the left. without the 0. And x greater than or equal to 2 will be here. The 2 inclusive. Okay. Part B. Write a verbal phrase for the compound inequalities. So just the opposite of what we were doing before. So I can first start with all real numbers that are less than -1 or greater than or equal to 4. And for the next one, write a verbal phrase for the graph of the compound inequalities. There's actually a misprint. Why don't you color in 0 and darken the middle? Okay, so to write this as a verbal phrase, it will be all real numbers that are greater than -5 and less than or equal to 0. Part D has you solving a compound inequality with AND. Okay, so here the first step will be to add 3. -3 and 3 cancels out. And on the left hand side, this would be 0. And then the middle would be p over 2. 0 plus 3 gives you 3. Now we need to take this 2 and multiply it to every single term. So 2 times 0 is 0. The 2 cancels out in the middle. 3 times 2 is 6. And this will be your answer. And to graph this, we would need to include the 0. And then I'm going to have to make this a little longer. So this could be 2, 1, 2, 3, 4, 5, 6. And then this needs to be an open circle. And then we shade everything in between. And for this one, it's a little slightly more complicated. We need to distribute 2/3 into the sum of 6q plus 18. So 2/3 times 6 is 4, and 4 times q gives you 4q. 2/3 times 18 gives you 12. Copy the rest. And now we can simplify this. Cancel. 7 minus 12 gives you -5. I'm going to keep working it down here. 4q less than or equal to -21. And then we can divide by 4. And then I can rewrite this as -1 and 1/4 q -5 and 1/4. And it will be better that you rewrite the answer so that the smallest number is on the left hand side, and don't make a mistake along the way. So your answer would be q is greater than negative 5 and 1/4, but less than negative 1 and 1/4. So now we can graph this. This is negative 1. This is negative 5 here, so negative 5/4 is about here, and we need to color in the circle. And negative 1 and 1/4 is about here, and it's an open circle because it's a less than sign. And then we have to shade everything in between. Open circle, closed circle. Okay, and I'm gonna label this as negative 1 and 1/4. Okay, now we have slightly more complicated compound inequalities. As you can see, you have 2 joined by and. So again, we need to solve these separately. So the first one will be x greater than or equal to negative 9. And for the other one, we can add 7 to both sides. Take down negative 8x. Negative 79 plus 7 is negative 72. And we divide by a negative number. Remember to reverse the inequality sign. So x will be less than or equal to positive 9. And now I'm going to graph each of them. So negative 9 is about right here. Inclusive. So everything to the right. And x less than or equal to 9 with 9 inclusive. So I'm going to use a different color. So then we need to just take the answer between negative 9 and 9. So your final answer will be negative 9 less than or equal to x less than or equal to 9. Now here we have a special case. Let's see. Subtract 13 to both sides of the inequality. So v will be less than negative 5. And this is an and. Okay, and we want to divide by negative 8. And because we divided by a negative number, we need to reverse the inequality sign. Negative 40 divided by negative 8 gives you a positive 5. So if we graph this, let's see. This is 0 and negative 1, negative 2, negative 3, negative 4, negative 5. Okay, everything to the left. For this one will be 1, 2, 3, 4, 5. Everything to the right. As you can see, there's no overlapping between this solution and this solution. So we have to write no solution. And if we compare this to the previous problem, there's an overlap in between. So this and tells us that both you need to include all the answers that satisfies both inequalities. Now part E deals with the situation of solving a compound inequality with OR, which means union. Union means we want everything. Okay, so minus 5, minus 5. R greater than or equal to 7. And for this one, R, just multiply 9 to both sides. R is still less than 0. Okay, so if we graph this, graph R greater than or equal to 7, it will be everything to the right, including 7, and 0 would be everything to the left. And your final solution will be r greater than or equal to 7 or r less than 0. Okay, let's try another practice question. Plus 1, plus 1. Cancel that out. Negative 10a less than 0. A, dividing it by a negative number, don't forget to reverse the inequality sign. So the a will be greater than 0. And for this one, subtract 10, subtract 10. Cancel that out. Take down 3a less than or equal to negative 15. Okay, so now we're dividing by a positive number, so we don't have to reverse the inequality sign. So negative 15 divided by 3 gives you negative 5. Okay, let's first graph this. A greater than 0. So open circle, want everything to the right. And negative 5, closed circle because it's a less than or equal sign. And we want everything to the left. And since it's or, we take everything. A greater than 0 or a less than or equal to negative 5 will be your answer. Okay, for this next type, it's also an or question, but now you have to collect like terms on both sides of the inequality. So here I will subtract 3n. Don't want to deal with the negative coefficient. And now I would add 2 to both sides. Okay, and this next one, subtract 3n. Add 4. N will be less than or equal to 0. Okay, let's graph. I'm going to rewrite this as n greater than 1 so it's easier to see. So 1, and we want everything to the right. And for this one, we want 0 inclusive and everything to the left. So your final answer would be n greater than 1 or n less than or equal to 0. And for this next problem here, let's collect like terms, plus add 2h. Subtract 5 to both sides, negative 12 less than 3h. So this will be negative 4 less than h, or h greater than negative 4. And for this one, we have, let's see, we can multiply 4 to both sides of the inequality. Subtract 8 gives you 28. And we can start graphing. This one's a special one. Negative 4 is about here. And since I don't have enough space here, I'm just going to let this be 28, even though it's not. Okay? And to graph h greater than negative 4, open circle on negative 4 and everything to the right. And to graph h greater than or equal to 28, I need to include 28 and everything to the right. But since this is OR, we need to include all the answers. So to write your final answer, it will be h greater than negative 4. Because we want all of these points due to the fact that it's or. Or means union. Union means everything. Okay? Geometry. Write one inequality that describes all the possible values of x. So we know that by logic, the sum of two sides must be greater than the third side. So x less than 5 plus 7, x less than 12. Reasoning, true or false, why? If A is a solution of x less than 5, then A is also a solution of x less than 5 and x greater than or equal to negative 4. Okay, let's first graph each of these inequalities. X less than 5 is probably about here, and everything to the left. And x greater than or equal to negative 4 will be everything to the right, and pass. Okay, and if A is a solution of x less than 5, meaning it's somewhere towards the left, then it's also a solution of both of these inequalities. I would say no, false, because when A is less than negative 4, okay, less than negative 4, it will not be a solution of both x less than 5 and, meaning in between here, x greater than or negative 4. Meaning if the solution A is here, then it cannot be in between here. You and 3 friends are planning to eat at a restaurant. So here we have 4 people in all. And all of you agree to divide the total cost of the meals and the 50% tip equally. Each person agrees to pay at least $10, but no more than $20. So I know my inequality will be 10, between 10 and 20 with inclusive 10. And then how much can you spend altogether on meals before the tip is applied? So first I'm going to let x equal the amount before tip. So if I pay x amount, or if they pay x amount, and to apply the tip, they need to add 0.15, meaning 15% of the amount they pay. So we need to take this amount and divide by 4. Okay? And now, once we have the inequality set up, we can start solving. Okay, so multiply both sides by 4. 40x. So this would be 1.15x less than 80. Okay. Then we divide 1.15 to all sides of the inequality. So if we take 40 divided by 1.15, you should get 34.78. And 80 divided by 1.15, you should get 69.57. So to write your answer, you should write from $34.78 up to $69.57. And I just rounded to the nearest cent. And this concludes our lesson.